Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 6.3 theorems about similar triangles. What will we be doing? Well, by the end of the lesson, you'll be able to explain how the mid-segments and angle bisectors of a triangle are related to the sides of a triangle. So basically, we'll be taking a line and cutting horizontally through a triangle, and we will also be bisecting an angle or cutting an angle in half. Why will we do this? Well, so we can apply that knowledge to solve for missing segment lengths within a triangle. How will you know you've mastered it? Well, you'll know that you've mastered it when you can correctly set up a proportion to find missing side lengths of a triangle using the angle bisector or a midsegment.
All right, let's go ahead and get started. The first thing we're going to look at is the triangle proportionality theorem, which states that you have a line parallel to one side of a triangle, which you can see right here. We are giving you that our two sides are divided proportionally. So looking here, you can see that we have side QR being split by R, making RX. So we can make a ratio stating QR over Rx. And that's going to be equal to, over here on the other side, we have QS and SY. So I don't like to say when things are easy because I think that's an opinion, but as far as things we do in this class, I would say that the triangle proportionality theorem is on the more easy side of things that we're going to be doing because it's so visual. When you have a triangle, using the triangle proportionality theorem, the proportion is pretty much being taken straight out of the picture. We have this segment over this segment equal to this segment over this segment.
You could almost use the bisector as the division marks for your ratio. So we could take our ratio that we wrote right here and pick it up and literally just slide it over, and you could see how it matches.
There you go. So we're going to go ahead and apply it now to a problem. So you can see in this picture that we have a parallel line to a side in the triangle. So we're going to go ahead and use the triangle proportionality theorem to solve this. So you can see that we have over on this left side, this point is creating 16 and x, and over here on this side we have this point making the 10 and the 5. So our proportion is going to be 16 over x, I have my colors backwards, 16 over x and 10 over 5. Go ahead and switch those so they match. And then from here we are going to cross multiply, creating 10x is equal to 80. And then we'll use the division property of equality by dividing 10 out, giving us a final answer of x equals 8. Okay, so that's about it for the triangle proportionality theorem. This is also known as the side splitter theorem, which is kind of a nickname that is very commonly used, which should make sense because you're splitting two sides of a triangle proportionally. So side splitter theorem and triangle proportionality theorem are kind of used interchangeably. All right, the next thing we're going to look at is the angle bisector theorem. So we have an angle bisector. You can see that that is what we're given right here. This angle is congruent to this angle by definition of an angle bisector. And from here, what we are going to say is that we have A and C, and we have B, and we have D. When you have an angle bisector in a triangle, that ray is splitting an angle in half. Well, it's also dividing the opposite side into two segments that are proportional to the other two sides of the triangle. So we are able to create a proportion that reads A to C is the same as B to D. And from here you would simply cross multiply.
Now, this one, just like in our previous problem, we can also use our angle bisector to show that it pretty much sets itself up as a proportion. So your angle bisector almost becomes your division marks or your ratio lines. So you can say that C over D is equal to A over B.
That did not drag right. Right there, you can kind of see it. And as we've talked in previous lessons, when you're setting up a proportion, it can be set up in a numerous different ways. I have it this way. It would not be wrong to say C over D is equal to A over B, which is a little bit more of a visual way of seeing it. If you notice, you're cross-multiplying the same things with the one I wrote first and with the one I wrote second. So it does not matter which way you do it. All right, so now we're going to go ahead and apply this to our problem. So reading here, we have AB is bisecting angle DAC. So I'm going to go ahead and put my congruency marks. We know that angle DAB is congruent to angle CAB by definition of an angle bisector. You're given that AC is 5, you're given that DB is 3, and that AD is 10. You're asked to find BC, so I went ahead and put an X there. Because you have this angle bisector, we're going to go ahead and set up our proportion. I'm going to set it up the same way that I initially did. So we had this 3 and this X, and this 10 and 5, so I'm going to go ahead and say that 3 is over 10 and X is over 5. And then from here we can cross multiply. It's not going to work if I'm highlighting, sorry about that. So we have 10 times X and 3 times 5. Then we can use the division property of equality, and 15 divided by 10 will give us a final answer for BC of 1.5. So that is the angle bisector theorem. Also, I would say on a scale of difficulty, this page of notes should hopefully feel more on the easy side of things. Now we're going to look at a midsegment. So what is a midsegment, and then what is a midsegment theorem? So we have two different things that we're going to be talking about here. A midsegment is a segment in a triangle that connects the midpoints of two sides of the triangle.
The midsegment theorem states that the midsegment is going to be parallel and half the length of the third side in a triangle. So basically it's going to cut the triangle, the sides in half, and that piece that's cutting the triangle in half will be 1/2 the length of the bottom side of the triangle.
And this all comes from triangle similarity. So this top triangle right here is similar to the big triangle by side angle side similarity. Because of that, we know that our angles are congruent. Well, if this angle is congruent to this angle, then these lines must be parallel by the converse of corresponding angle theorem. Also, we can tell that this is 1 to 2, 1 to 2, so therefore this is going to be half of whatever this is, because this triangle is exactly half of this big triangle.
Or you could say the big triangle is 2 times the little triangle.
Exactly.
Which is basically the converse.
So make sure if you need to pause this video, you have a triangle, 2 triangles in this box. So one, what is a midsegment? It's connecting endpoints. And then on the other one, we're talking about the midsegment theorem and what it is. So now we're going to go ahead and use the midsegment theorem to solve for our first problem. We could tell that E is a midpoint based on the congruency marks, and we can tell that B is a midpoint based on the congruency marks. Because E and B are both midpoints, we are able to say that EB is a midsegment, which tells us a whole lot of information about this problem. So the first thing it's asking us to find is, what is the length of EB? Well, based on what we just talked about, we know that a midsegment is exactly half of the length of the side it's parallel to. Well, that would be 18. So we're able to say that EB is half of DC, which is half of 18, giving us a length of EB of 9. We also know for finding BC that B is a midpoint. So if AB is 10, then BC must be 10. And then lastly, using segment addition postulate, we are able to say that AC would be both AB and BC together, giving me an answer of 20. We're going to go a little bit more difficult with the mid-segment theorem here. This problem, notice that you're not given anything other than the force. So you guys have to see the triangles within the triangles. So we have this triangle right here, but then we have this next size, kind of like nesting dolls. You know what those are. What I want you to see, though, is that this point is a midpoint along this green side of the triangle. Because of the force here, this is also a midpoint, which means we know this is a midsegment of this green triangle. Then you have this big triangle. Well, I know that below this point is 8. Well, I know above this point is also 8 using segment addition. And it's going to follow on the same on the right side because we have an isosceles triangle here. So we have 8 below and 8 above. So this segment here must be a mid-segment in this blue triangle. Well, we don't know what length any of them are, but I am given a clue right here. The sum of all 3 horizontal sides is 168. Well, I know sum means I need to add those 3 horizontal sides together.
So now we kind of want to be smart as to how we label these different segments, because most of us don't really like working with fractions very much. We don't want to have a lot of fractions. So what we will then do is let's go ahead and start with our smallest piece. And let's call our smallest piece x. Well, you know that it is a midsegment, so you know it's half of the length of the piece below it. So the piece below it has to be twice as big, or 2x.
And then following with that pattern, you know that this is a midsegment to the big triangle, so this 2x is half as big as this, so this must be a 4x. So now I have 3 terms that I can plug into my equation to solve. We have a 1x, a 2x, and a 4x. From here, you're just going to use your algebra skills to solve this equation. We know 1x, 2x, and 4x can be added together to make a 7x. And then we're going to use our division property of equality, divide 7 out, and you end up getting that x is equal to 24. Now the question is asking us to find the length of each horizontal side. Well, if I know that top horizontal line is just x, then it must be 24. If the x is 24, well, times 2 would give me 48. And down here, if x is 24, well, 4 times that would give me 96.
So the biggest thing to remember when doing this problem, or problems similar to these, is getting your individual floors or layers or levels marked appropriately. And I would recommend always starting, or making yourself a note to always start with the smallest piece.
I would definitely add that to your notes. Start at the top.
And definitely calling it x, because had we started with the bottom instead, we would have had x at the very bottom, and then the next one up would have had to have been 1/2 x, and the next one above that would have had to have been 1/4 x.
Which wouldn't be wrong.
And it will still work.
You're just now having to have an equation with these fractions, which isn't ideal for many people.
Some of you may welcome the challenge and enjoy it, and if you do, by all means, have a blast.
Yep. All right, we have just one more problem to do, dealing with our midsegments. It's just more of a complicated equation. Based on this, we can tell that n is a midpoint based on the congruency marks, and m is as well, so nm must be a midsegment. So I know nm is half of cb. When it comes to these equations, I tend to, similar to the last problem, rather than cutting things in half, I like to work the opposite way and start at the top and double it. So my equation I'm going to make is that the bottom 6x plus 2 is 2 of these, because this is half as big. So I'm going to double it to make it the same size. And then from here, you would just use your algebra skills to solve your equation. So we're going to go ahead and distribute right here. 2 times 2x and 2 times 4 gives me 4x plus 8. I'm going to use subtraction property of equality to move that 4x over. And I'm going to use the subtraction property of equality to move the 2 over. Lastly, I'm going to use the division property of equality to divide 2 into 6, giving me an answer of 3. So these last 3 problems, you can see we were just using the fact that midsegments are exactly half of the side it's parallel to, or the bigger side is twice as big as the midsegment. So hopefully you guys feel confident in setting up the proportions created by segments inside of triangles. As always, if there was anything that gave you some trouble or a hiccup somewhere along the way, please reach out to us via remind or through email.
Hey, Mrs. Weichel.
Hey, what, Mrs. Nets?
What is 5Q plus 5Q?
10Q?
You're welcome.
Thank you. Thanks for joining us. We will talk to you in 6.4.